Okay, today we're going to look at how to evaluate trig functions using the unit circle. Chapter 12, topic 5. So recall here is our unit circle, and I am going to need this unit circle to do all of these problems. So I'm going to go ahead and make a copy of it in just a second. But first, let's talk about how we can do, whoops, let me fix my mouse real quick. What we can use the unit circle for. So if you remember a trig function, sine, cosine, and tangent, they're all ratios of the different sides of a triangle. Sine, SOHCAHTOA, sine, cosine, tangent, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. Sorry, that's an A. It's supposed to be an A. Tangent, opposite over adjacent. So these apply to triangles. Now, if you think of a point on the unit circle, for instance, here is a point on the unit circle. Well, you can think of this as creating a triangle that has a 90-degree angle, a right triangle, because the distance that you go over to get to this point is simply the x coordinate. So in this case, square root 3 over 2. And the distance that you go up to get to this point is simply the y-coordinate. So in this case, 1/2. And remember, the distance from the origin to the point is 1 because this is a unit circle. The circle, the radius is 1. So the distance from the center to this point is 1 unit. Now, and remember, this was a 30-degree angle. And this is a right angle. So what we see here is we actually have a right triangle. Not only that, it's a right triangle where we know all the side lengths. Okay, so we can evaluate sine of 30 degrees. We can evaluate sine of this angle because we know all of the sides. So for instance, if I wanted to say sine of 30 degrees, well, sine is the opposite side over the hypotenuse. So the opposite side is 1/2. The hypotenuse is 1. So 1/2 divided by 1, which is just 1/2. So sine of 30 degrees is 1/2. And that's just the y-coordinate here. Now, if I wanted to do cosine of 30 degrees, now I'm looking at the adjacent side over the hypotenuse. So the adjacent side is this, and it's over 1, so divide it by 1 and it's the same thing. So the cosine of 30-degree angle is the square root of 3 divided by 2, which is just the x-coordinate. We can also do the tangent of the 30-degree angle. However, tangent usually requires a little bit more work than sine and cosine. Sine is just the y-coordinate, cosine is just the x-coordinate, but tangent is the opposite side over the adjacent side. Okay, TOA, opposite, 1/2, divided by the adjacent side. So that's actually going to require a little bit of work. So we have 1/2, the opposite side, over the square root of 3 over 2, which is the adjacent side. Okay, so since we're dividing fractions here, we can convert them to multiplication. So it's 1/2 multiplied by 2 over square root 3. All right, remember you just flip the one that's being divided. When you turn it to multiplication, just flip over the one that's being divided. We see here that a factor of 2 on top and 2 on bottom will cancel out. We end up with 1 over square root of 3, which is technically the correct value. It just is not in the correct form. So to put it in the correct form, you just multiply it by the square root of 3 over the square root of 3. And what this is going to do is the numerator, 1 times the square root of 3, is square root of 3. And now the denominator, square root 3 times square root 3, is the square root of 9. And the square root of 9 is just 3. Okay, so doing this allows us to put it into the correct form where we do not have a radical in the bottom. So now you can see we don't have a radical in the bottom, we have a whole number, which is what we want. So tangent of 30 degrees is the square root of 3 divided by 3. Okay, so that one was a little bit hard, but now we have all of the different trig functions for a 30-degree angle. Okay, sine of a 30-degree angle is 1/2. Cosine of a 30-degree angle is the square root of 3 over 2. And tangent of a 30-degree angle is the square root of 3 over 3. So that's how we can use the unit circle to evaluate trig functions. Just a review on how to do each of the trig functions. Cosine, that ended up being only the x-coordinate of the point. Sine ended up being the y-coordinate, and the tangent was the y-coordinate divided by the x-coordinate. Okay, so we're going to evaluate a couple of different trig functions at different angles. So I'm going to get a copy of the unit circle that I can use now. All right. And I want to evaluate each of these trig functions. So basically what we have to do is just find the angle, and then whether it's sine or cosine, that'll tell us, or a tangent, that'll tell us what the answer is based on the angle. So first we have a 225-degree angle. So 225 is right here, positive 225. Now since we're doing cosine, we're going to want the x-coordinate. So cosine of 225 degrees is negative square root 2 divided by 2. And that's the answer to number 1. Number 2, we have sine of 210 degrees. So sine of 210, let's go to 210. Where's 210? 210's right here. Sine is the y-coordinate, so the sine of 210 degrees is negative 1/2. Now sometimes the angle can be a little bit tricky to find. Maybe the angle is negative, maybe the angle is in radians and not degrees, or maybe both, like in number 3, cosine of negative pi over 2. Not only is this negative, it's in radians. So first we need to figure out pi over 2. What is pi over 2 in degrees? So pi over 2 converted to degrees means to multiply by 180 over pi. The pi's cancel, you get 180 over 2. It's a 90-degree angle. So pi over 2 is just 90 degrees, which is right here. However, we have a negative sign, so we're looking at negative pi over 2. So instead of going around 90 degrees this way, we're going to go around 90 degrees this way. So it's right here. So we're doing cosine of technically a 270-degree angle. Okay, this is how we're going to find our answer, is by looking at the 270-degree angle. This is the same as a negative pi over 2. Now that we found the angle, its cosine, we want the x-coordinate, and the x-coordinate is 0. So cosine of negative pi over 2 is equal to 0. Okay, tangent of pi over 3. So first we need to find pi over 3. Pi over 3 is right here. Now since we're doing tangent, we have to take the y value and divide by the x value. So the y value is square root 3 over 2. The x value is 1/2. So I have to divide these fractions, so I'm going to turn it to multiplication. Square root of 3 over 2 stays the same, but now I multiply it by the flip, by the inverse of the denominator, so multiply by 2 over 1. So the factors of 2 will cancel out, 2 on top, 2 on bottom, and I'm left with the square root of 3 on top and 1 on the bottom, which is just the square root of 3. So tangent of pi over 3 is the square root of 3. Okay, next, sine of 5 pi over 3. So let's look for 5 pi over 3 right here. And since I'm doing sine, it's the y-coordinate, so negative square root 3 divided by 2. Number 6, cosine of 570 degrees. Well, you'll notice 570 is not on here. The highest this goes is 360. It goes all the way around, makes a full rotation, and comes back to 360. So what this is telling us is 570 is going to be more than one full rotation. So I'm going to actually have to figure out how much more it is than one full rotation. So I'm going to take 570, I'm going to subtract 360 to figure out how much more it is. So 0, 1, 2. So this is a 210-degree angle. It goes around one full time, and then it goes around 210 degrees more. So it's right here. So we have this angle right here. Cosine of a 210 is the same as cosine of 570. We want the x-coordinate since it's cosine, so the negative square root 3 over 2. Number 7, cosine of negative 7 pi over 3. So you'll notice 7 pi over 3 is not on here. So let's turn it 2 degrees and see what it is. 7 pi over 3 multiplied by 180 over pi. 7 times 180 is 1260 divided by 3. So this is a 420-degree angle, which is larger than 360. It's more than one full rotation. So let's subtract 360 to see how much more it is than one full rotation. So 420 minus 360. Minus 360, 60 degrees. So 7 pi over 3 is a 60-degree angle. But remember, we're looking for negative 7 pi over 3. So that would be a negative 60-degree angle. So 60 is right here. Negative 60 is going the other way. It's actually right here. So what we're actually looking at, where we're going to get our answer, is from the 300-degree angle. Okay, negative 7 pi over 3 and 300 degrees are the same thing. They evaluate the same. So now that I know where the angle is, I just need to look for the x-coordinate because this is cosine, so 1/2. Tangent of pi over 6. So pi over 6 is right here. We did this one actually at the beginning. It's going to be the y-coordinate over the x-coordinate. So we have 1/2 over square root 3 over 2. Change it to multiplication. So 2 over square root 3. Factors of 2 cancel. 1 on top, square root 3 on bottom. But remember, no square root in the bottom. So multiply by square root 3 on top and bottom. That gives us square root 3 on top and square root 9 on bottom, which is just 3. So we get our answer for tangent of pi over 6, square root 3 over 3. All right, and lastly, the cosine of negative 45. So a 45-degree angle positive is right here, but negative, we would have to rotate the opposite direction, so it's down here. It's actually a 315-degree angle. Since we're doing cosine, we want the x-coordinate, so it's square root 2 divided by 2. All right, and this is essentially how we can use the unit circle to evaluate different trig ratios.